share what I have achieved part of this final project for this Introduction to Machine Learning course. As you can see, the primary goal for this project is to determine the price by the room location and various different measures that we would like to understand and consider when we are looking for a Airbnb in any country. This time, currently, I'm going to focus on only the European cities and their Airbnb prices. So in this project, in this data set, I'm going to use the multilinear regression model and the KNN regression model to process the data that I have downloaded from the Kaggle dataset site. So as you can see that I've provided the resources here where I've got the data from. Now on to the project. First thing I did was to implement the data and importing the data from the various CSV files. So the data, the way it was available was it was broken down into each cities, so that what I had to do was to download a bunch of different cities in CSV format, the data of a bunch of different cities into CSV format, and then I ended up combining all the data into one large CSV file so that I can kind of implement my model on that data set. So part of the data importing step, I have gone through the various data sets that I downloaded, and at the end I've created a combined city data CSV that contains all the data that is I'm going to use part of this project. So first step was to data import. That's what I have achieved here, and as you can see in the output, you can see the room types and various different information that I am retrieving from the data, and different columns that are available part of the data. Once I have the data all combined into one CSV file, I am creating a factory and data factory, and storing that data into a data factory, um, and just renaming the column to price. So that's what I'm doing here. Once the data, once you have the data, the next step is to provide and do the data cleaning. So in this step, I am doing the data cleaning. So as you can see, I'm just showing the data factory. So this data factory contains all the data and all the columns so that we can visualize how data looks. Um, in the next step, I'm providing the information about all the columns and that are available, and their data types. Then I'm just listing out all the columns, and also the just showing and visualizing the columns with their data types. And in this step, I'm just describing all the columns, so various actual data that I'm retrieving from the CSV file. So these are just the steps to kind of review and kind of normalize the data, just to see how and visualize it, how it looks. Um, Once the data import is done, once the data cleaning is done, we'll still be doing more data cleaning down the line, but this was just to kind of see how the existing data looks, not necessarily still removing the duplicates and all of those things. This was just the visualization, just the initial data set that as a raw data that's available. Once all these steps are done, we are kind of going into now the data analysis step, where I want to review and see what are the different parameters, columns that I can use and pick as my features, so that I can run my model against it. So part of the EDA, I'm just doing all the necessary imports, just printing all the values that are null or not null. Just again, just showing the columns and the data that's available. And also, before I go and clean all the data, I kind of wanted to see how data looks with the different comparisons. So, like, meaning this step, I'm kind of showing how the data, how the Airbnb price um, uh, looks according to the total number of Airbnbs that are available. So this is one of the data just to visualize how it looks into the price distribution plot. The next step, I'm also plotting the Airbnb by city and the price. So I'm doing the box plot here, so you can see the different prices for each city. So for example, like Paris, you have 5,000, or 150,000. London. So these are all the different price distribution by the city. Just to visualize the data. Um, Also, in the next, I'm also comparing the room type and the price. So like a private room, entire home, shared room. So what are the different types of Airbnbs that people pick, and what are the prices? So just kind of creating a different plot to see how it looks and how it differentiates between the different room types. Also created a correlation matrix just to see and kind of understand which features to pick. So I quickly plotted my correlation matrix from my data just to see what are the features that are much more important, which ones are correlated, so that I can pick the correct features when I'm doing my model programming. So this was also the step that I implemented. um, Now, I'm just gonna dig into the um, uh, pre-steps of my model and my data that I'm gonna run through my model. So I'm just doing features. So I'm just picking up what are the features that I want to focus on, which ones are more correlated, and which one can be more helpful to understand my data better and provide a good quality prediction using my model. So um, just doing this step to see what kind of features that I could pick. Then I'm also doing a encoding of my categories like city, room, type, and then also dropping the columns that I don't require. So those are the steps that I kind of did just to view the data and just to understand my data properly before I do any processing or run through my Airbnb data through any model. So these are just like a pre data analysis step. Once the data was analyzed and I did all of these steps to understand my data better, I went through the data to create a different test sets, training sets, just so that it'll be easier for me to use them in my linear regression model. Also implemented the scaling for the KNN regression model. So that those are the two steps that I did, so that I can probably use a KNN model to compare with the linear regression model, so that I can compare the outputs and see the R square values, so that I can say that which model is able to predict proper data. So that's the step I performed here. That kind of gave me the detailed information. Now on to the model and the feature engineering. So what we are doing here is I'm just creating a linear regression model, and just doing passing my x and y train data set to start the training process for my model. um, Now you can see here, just doing the necessary imports before I do any processing. Also did one extra step before I run my data through the models, is implemented a OLS regression results, just to kind of see the R squared and the p values that are available that are for my data set. So I implemented this step just to get the better understanding of the OLS regression results. Now on to the next step. We'll be writing so now we are actually going to implement and process our data through the linear regression model and k-neighbors regression model. So these are the steps that I'll be performing, part of my code. So I'll be loading the data set. I'll be doing the data analysis, handling the missing values, feature selection. Then I'll be building the model and training them. And I'll be implementing multilinear regression and also the k nearest neighbor regression model. So I'll be implementing two different models in my code base. Then I'll be evaluating the results and data set that returns the values. And also I'll be plotting the predictions and actual prices for both the models so that we can visualize how the models are performing. Um, so part of my code, what I'm doing is just implementing a necessary imports. As I mentioned before, we are just loading the combined CSV file where all the cities data is combined into one CSV. Like I said, it'll be much more easier for us to read the data from one CSV rather than going through all the CSV again and again. So that's why I combined them into one, storing them into data factory. Also just renaming the column here again, displaying all the rows and the data set that's available. I'm dropping the missing values, so just cleaning up the data set here. Doing the feature selection, so just picking up the columns and picking up the features that I would like to highlight. So doing the feature selection here. Also doing the encoding of the variables. Then I'm determining the features that I would like to drop. So in this case, all these columns that I'm going to be dropping, just so that they're not very useful. Then comes the step where, so these are the steps I was doing where I was loading the data, cleaning the data, and then doing the analysis on the data. Now what I'm going to do is implement the implement the preparation for the data. So I'll be creating the train set, test set, so that I can run them through the model. So this is the step where I'm splitting my data into training and test sets. Then also added a validation step where I'm making sure the data is correct format. And then I also implemented the scaling for the KNN model so that we can run through the KNN model, our scaled data set. Now, the next step for us is to implement the models and then train them. So first of all, what we're going to do is we're going to implement a multilinear regression model. So what I'm going to do is create a multilinear regression model and then run the train and test set on it. So I'm going to train the model. So now model, once I pass my train data set to the model, I'll be training them. And then using the stats model to kind of get the detailed summary of the data that model was trained on. So that is what I'm doing here. I'm printing the whole summary of the trained model and the data that we can validate. Then for the next step, I'm implementing the second KNN model, regression model, so that I'll be creating the K regression model and then pass the scaled data set to the KNN model so that we can see the difference between the linear regression and the KNN model, how they both are performing, and we can come up with a conclusion that which model is better at performance. And then in the next step, what I'm going to do is I'm kind of evaluating the results and predicting them, so that I implemented a prediction step for the linear regression model and then prediction step for the KNN model. And then finally at the end, I'm just plotting all the data that I have available for the linear regression model and the KNN model. So This code is covering pretty much from end to end. So first step to the last step, meaning the data loading, data cleaning, data analysis, then feature selection, then training and test data splits. So preparing the data sets, then creating the models, running the data through the models, and then evaluating the model, and then displaying the data that model generated. So these are the steps. So in this case, what we can kind of see after the data was ran on the and the model was trained, we can kind of conclude the R score, R2 score for both the models. So for multilinear regression model, we can see the R2 score is 0.24, and then for the KNN regression model, the R2 score is 0.28. So we do see here a little bit of anomalies that we can see on the chart. So we can implement certain various ways that we can try to eliminate some of the anomalies, but largely we can see here that the KNN model has a better performance, which is much more closer to the line versus the multilinear regression model. So our data is much more aligned to the KNN regression model. In the next step, I'm also doing something very similar, but just processing the data a little bit differently. I'm implementing the linear regression model and KNN model, performing the similar steps from 1 to 7, meaning the loading the data, analyzing the data, cleaning the data, feature selection, running, creating the model, results, and then plotting the data. So in the first test run and first code run, we can see that a multilinear regression model is is a little bit less efficient than the KNN model. In this case, with the data set I have, since it's much more consumer related data, there are much more other factors that affect this data set. So in specific Airbnb data and linear regression and KNN regression, the score that we have received 0.24 and 0.2 is much more acceptable versus if it's a financial data or it's let's say any other type of data that is there might not be much more acceptable this score. But in this test data that I have, because the other factors are much more prominent, 0.24 or 0.28 is much more, I guess, acceptable in this case. Similarly, what I'm doing here for the second run, I implemented twice where I'm doing very similar steps, like I mentioned. So creating the data factory with the data, displaying the data, then doing the analysis on the data, so describing and then displaying the data according to each feature that is much more that I can think that much more value added. So in this case, I'm doing the price distribution by city, price distribution by room type, count of listings by the room type, count of listings by the city, and then just the different model that I'm plotting here by the selected numerical features. In this case, it's price, person capacity, cleanliness. So just different features that I would like to display. So I selected those. I'm also doing the distance to the city center versus the price. So sometimes you want to see how far, how are the prices and how are the cities and Airbnb costs that are different according to the distance from the city center versus the price. Also, sometimes it depends on the number of rooms that are required compared to the price. So just plotting different data set so that we can visualize it before I run them through the run them through the model. Now, just again, third step, very, very similar to previously. What I did was just handling the missing values, feature selection. So just selecting all the features that I think are much more important to review. So I did that again, encoding the categorical variables. Then also doing the correlation matrix here, so that we can see how it's correlated. Um, then just doing the data split. So just splitting the data into train and test set, and also ensuring the data is in correct format. And then also scaling the data and the features for the KNN model, so that when we run the data through KNN model, we can run the scale data on it. Again, the step we're going to be performing is now creating the model and also running the data through the model and training the model. So in this step, I'm creating a multilinear regression model and running the data into the train set and into the linear regression model. So you can see here I'm doing the fit on the model, meaning we are training the model, and then eventually we'll be predicting the model. Also doing the stats model to see how the model is performing. Similarly, running the scale data set to the KNN model, and also training the model. And then in step 6, I am just predicting the data for the linear regression model, and in 6.2, I'm predicting the KNN model with the scale data set. Finally, I'm plotting all the predictions so that we can visualize it. So as you can see here, we can see the multilinear regression model. R2 score is also 0.24, which is similar to our previous run. And also the KNN regression model also has the R2 score, which is very similar to our previous run. So here also we can see the KNN regression model is better performance than the multilinear regression model is what's considered. Higher the R2 score is what usually is considered a good model. Again, we do notice here there are some anomalies that we can try to handle in different ways, where we can remove some of the anomalies from our data set and try to optimize it. I just wanted to keep some of the anomalies just to kind of show how it behaves and how we can handle it, so that everyone can be aware. Now that I've ran the dataset twice and trained two models two different times, one more thing I wanted to kind of implement was the hyperparameter tuning. In this case, for the hyperparameter tuning, I'm going to use the KNN model. And then evaluate the performance. KNN model is using the grid search CV to find the optimal number of the neighbors. So here you can see I implemented a grid search. So these are the different neighbors. Then I'm performing a grid search on my grid. So you can see here I created the KNN regression model, and then just creating a grid search for my model. And then I'm doing a training my grid search using the scaled dataset. Since we're running the KNN regression model, just passing the scaled dataset. And then you can see here the hyperparameter is 11 in this case. And now we're going to be evaluating the KNN model after we completed the hyperparameter process on it. What I'm doing here is just implementing and evaluating the values that R2 score received or achieved after we ran the hyperparameter model. Hyperparameters we implemented after we implemented the hyperparameters. We are comparing now R2 score for the KNN model. So here we can see the comparison with the initial model runs we did. So linear regression, KNN regression, and tuned KNN regression. So initial regression, we can see, as you can remember, it was 0.24 for the linear regression, and then KNN regression was 0.28. After we ran through the tuned KNN regression model, we can see the R score was improved quite a bit. Not quite a bit, but I would say it was improved compared to the linear regression model to 0.30. So this means that the KNN model shows the slight improvement performance compared to the initial KNN model and also the linear regression model. It also performs better than the linear regression model based on the statistics, this matrix, like I mentioned. So that's kind of what helped implementing the hyperparameter. In summary, what I want to say is that the key findings were, the linear regression model R square was 0.24, KNN was 0.28, and then after we did the hyperparameter tuning, we kind of helped KNN model to improve its R2 score to 0.30, and that kind of helped improve the performance of the KNN model with the tuned data set. Precision and recall matrix that were used, were just implemented different models and tried to use the data for the regression problem. And and then the insights and the next steps. So after we implemented the hyperparameter tuning, the data set was I guess the data set kind of improved a little bit, but we can also improve and add a wider range of hyperparameters for the KNN to see if we can improve the KNN R2 score even further. So those are the next steps that we could take. So basically, this kind of shows that our data is with the linear regression, our data is performing at moderate level, and then with the KNN model, our data performs a little bit better in terms of the pricing that we can see. So these are the different correlation metrics. We can see here the number of bedrooms versus the price, and distance to the city center, how our data is performing. So and also displaying all the count of listings by the city. So these are the different charts that I was trying to plot to visualize the data that we have available in this data set. So this is kind of what I have implemented a part of my final project, and I've tried to cover all various steps, and I've tried to explain my findings into this analysis here. So yeah, I tried to cover almost all steps in terms of data loading, analysis, handling the data, cleaning the data, feature selection, model building, training the model, evaluation of the data, and also the plotting the data. So I hope this helps to understand what I'm trying to do here and how the prices for the Airbnb for the European cities is predicted using the various uh, ways. In this case, I'm using the linear regression model and the KNN model. Thank you very much.